I'm Krycho. I'm going to talk a little bit about TypeScript and Ember, talk a bit about the benefits and the trade-offs and where the future will be going with TypeScript. This is me and my family last fall. I have a lovely wife and a pretty hilarious pair of girls, almost 6 and almost 4 now. I work at Olo. I'm a senior software engineer. I work almost entirely on an Ember app every day, have for the last 2.5 years. We do online ordering for restaurants, white label. So if you order from Five Guys or Wingstop or Applebee's or Chili's or all sorts of places, we have something like 50% of national brands run through us at this point. We do that. And my experience over the last 2 years is building an Ember application that is currently our mobile ordering experience on the web. And over the course of the rest of this year is turning into a responsive, progressive web app. So it'll be what you use for any of our white label platforms. And it's pretty fun for the most part. Ember has been a good choice for us. I also am one of the maintainers of ember-cli-typescript. I didn't aim to become an internet famous maintainer of ember-cli-typescript, but a year ago, after we'd been using it for a few months, the people who had kind of led the charge up to that point ended up in other jobs and other roles where they didn't have time to and may not be using Ember at all. And nobody else was doing it, so here I am. Which is, I think, how most open source maintainers end up maintaining things. However, happily, I'm not the only one anymore. There's a core team of about 4 of us, and we're making it pretty awesome. A year ago when I showed up, it was not an awesome experience to use TypeScript in Ember. Today it mostly is, so I'm going to talk about that a bit. I'm going to start by saying, what is TypeScript? How many people in the room have heard of TypeScript? Okay, so pretty much unanimous on that front. How many people in the room have used TypeScript? Much less unanimous on that front. Roughly an order of magnitude difference there. So TypeScript is basically types on top of JavaScript. Now I say basically because there is one specific construct in TypeScript which doesn't just get stripped out as just a type annotation that literally just gets erased at compile time. So strictly speaking, TypeScript is a compiled to JavaScript language, the same way that CoffeeScript was and is, the same way that Elm or F# or all sorts of other things can be at this point. But for our purposes today, it's close enough, and really in practice almost all the time, it's close enough that you can just think of TypeScript as type annotations sitting on top of TypeScript that give you help. Lots of help. So cool, I guess, if you are into type theory, like I am. But for a lot of us, the question is really, how does that matter as a developer working day to day? And in our experience using TypeScript at Olo, there are 2 big differences. One of those is, how many of you like documentation for the libraries you use? We're back to near unanimity. The biggest thing we get from TypeScript is essentially having always up-to-date documentation for the classes and methods and functions and things we're doing in our code base of at least that most basic sort of, this thing expects you to pass in a string, not an object literal. This thing expects an object literal, not an array, etc. As well as the types of things that should be on those object literals or arrays or whatever else. It's just always up to date, checked for you documentation. So even if you're a dynamic languages fan, you get some value out of using it even as a sort of lightweight documentation tool. The other thing that TypeScript can help with, if you use its strictness settings, is, well, how many of you love seeing your ray gun errors include undefined is not an object? No hands went up this time. If you turn on some of the strictness settings, you can make it so that if you see this, you did it on purpose to yourself. You explicitly opted into a scenario where you knew something could be undefined, and you said, no, trust me, really, TypeScript. And TypeScript says, okay, well, you're on your own then. But as you dial down the tightness settings, the strictness settings for TypeScript, you can make it so that you just see a lot less of this in production. And given the proportion of errors in our ray gun error reporting buckets that are this, that's a nice outcome. It's not Elm, where the number is 0, but it's a lot closer to that than it was before we had TypeScript in our application. Some of you who have experience with other typed languages, some typed languages do genuinely inflict pain on you in the using of them. I've written a lot of C and C++ in my life. C++ can be a painful experience of writing types and not getting that much help out of it. And the way I like to describe TypeScript is to say that it gives you a lot of benefits without a lot of the sucking that is there in a lot of strongly typed languages that most people have familiarity with, in a way that means that writing types and using types in TypeScript costs less relative to the benefit you get out of it. And I'll show you a little bit of why now. So this is what TypeScript looks like. And I've got comment annotations in there for reasons that you'll see in just a minute. This, you will note, looks just like JavaScript. But unlike your normal JavaScript, this is fully type checked. Those are all resolved as having, well, types. So the first one there, let greeting equal hello, is a string, and TypeScript knows it's a string, and I didn't have to tell it that. Now, if you've used modern C++ or C# or Java or whatever, you're used to this, auto, var, etc. Where it gets a little more sophisticated is when I declared let an object be something more complicated, for real, truly. Well, TypeScript knows that this is an object which has a key named string on it, which is pointing to an object which has a key named more, which is a string, and a key named for real, which is a Boolean. It inferred all of that. And if I try to assign things to it that don't belong to that, TypeScript will say, hey, did you mean to do that? Now, if that sounds overly restrictive and you're thinking, yeah, but sometimes I build things up over time, TypeScript has easy ways to let you do that as well. The point is, you can say, this is an object that has this shape, but you don't have to explicitly write out the types every single time you do that. TypeScript infers the types for you. And that goes for this person class at the bottom as well. You can define a class, person, with a name with an initialized value, and an age with an initialized value. Hi, I'm Chris, I'm 30. I guess that officially makes me an old man now. This automatically infers that name is a string and age is a number. And if I try to assign, if I do new person and I try to assign name equals 30, TypeScript will say, hey, I don't think that's what you meant, and you'll get a compiler error. So TypeScript can and usually does infer most of what you need it to the extent that writing ordinary app-level Java or TypeScript looks and feels mostly like writing app-level JavaScript. You don't notice it. You just kind of get better autocomplete and help if you accidentally pass the wrong argument type in. And I'll show you this in the context of an Ember app later, and an Ember component, what that might look like, etc. One thing I want to call out here that makes a big difference that's kind of weird. In most languages that most of us have used, a type, when we think about it, is a name. So person on that previous slide would be the name of the type, and that would be really important. If I had another type that had the same fields on it, but it was called human instead of person, those would not be interchangeable. In TypeScript, that's not true, because types are just shapes. They are not names. And this has the really interesting effect that if you define a type, this is a type alias here, saying the shape of a person in this case is a name which is a string and an age which is a number. Well, I can pass that into a function, and I can say this thing that you're passing in has to be a person. And then I'll return, I messed up my slide here. Appellation should read something like your name or you or something like that. I was trying to shrink the slide size, the amount of text on the slide. So imagine that appellation is just, this person is p.age years old. Now I call it here with an object literal. There's nothing about this object literal, name Chris, age 30, appellation there could be p.name. Nothing about this says this is a person, but it has the right shape. It has a name that's a string, and it has an age that's a number, and that's enough. And it could have more fields on it. It has to have at least those fields on it, but it could have other fields. It could have object methods on it. It could have all sorts of things on it. Doesn't matter. It matches the shape here. That's enough. Shapes can include methods. They can include properties. So I've added to this person speak and shout. Shout is sort of the inline, the bound method versus an attached function. So you can see there's slightly different syntax between these, but you've got a person shape. And again, I would just need to pass something in that had these types on it. A speak method, a speak function that took a thing to say that was a string and gave back a string, or something to shout that was a string and gave back a string. And here you can see how we write type annotations when we do annotate a type. You just write the name of the variable, just like you would in JavaScript, and then after it, the name of the type. And these type alias declarations like this basically are designed to look like an object literal. The difference is that instead of assigning a value after the colon that separates the key from its value in an object literal, you're supplying the type. So name, instead of getting an actual concrete string, you're just telling it, hey, this needs to be a string thing. And as it turns out, there are actually 3 ways to define a shape. One of them are type aliases, which we've just seen. One of them is an interface. The main differences between interfaces and type declarations have to do with how they interact with the rest of the system. So interfaces can be implemented by a class. A type is just a shape. It can't be implemented. But type declarations, these type aliases, let you build things up more the way you might in an F# or a Haskell or an Elm or something like that. Interfaces are more oriented around C#, Java, class object-oriented style programming. And then we have a class declaration. And for the most part, this is just like BS6 classes, if you've seen those in your code. They define in TypeScript, though, a type that is a shape and a way to build it. Again, as I said, they're not building a name so much as they're building a shape. And I like this example because it's kind of mind-bendy for people with Java and C# backgrounds. We declare a class that is a person, that has an age on it that's a number, and it's got a constructor, and it assigns the age that you pass into it. And we have that same describe function, but I actually fixed this one. This person is p.age years old, and we can call that with an object literal. There's no new here. There's nothing that associates this with the other type, but it matches the shape. What this means is that in practice, a lot of times you end up writing your TypeScript just like you were writing really fairly dynamically typed JavaScript. You've just got a bit of annotation that you can pass around that says, hey, the shape I expect here is this. You get that sort of sense of, I have documentation that just stays up to date, and it doesn't feel very heavyweight. The places where we need type annotations only end up being things like the arguments to a function. This function, describe, always returns a string, but I don't have to write down that it returns a string because the TypeScript compiler can see that it always returns a string, so it knows that. And if I try to take the return value from describe here and treat it like it's a number or an object literal or whatever else, it'll just say, no, that's a string. You can't do that. And I'll actually show you some of this in some live code in a little while.
Will it not complain to you for including a name that's not included in the class definition?
It will not, because all it cares is that you meet the minimum definition there. So name can be on it. You could have 47 methods on it. You can do whatever you want, as long as it has an age field. And in principle, in certain cases, you can constrain things to with an interface. You can constrain it that it needs to have a constructor of a certain shape. It's pretty rare that you do that. When we wrote the type definitions for Ember itself, we did have to do that. I will not tell you the horrors that it took to write type definitions for Ember's object model. They are deep and scary. Ember's object model is amazing, but it predates modern JavaScript stuff by a lot. It was hard. I'll show you some of that. So that's kind of like, here's TypeScript in a nutshell, for those of you, just since most of you don't have good experience with it. And the question of, does it work, is it easy to use in an Ember app, etc., is mostly yes. We have about 40,000 lines of code in our application repository, about 50-50 tests and app code. And it all type checks. We get type errors and fix bugs with type errors pretty regularly. The process of making it type check, I found dozens of small bugs and a few pretty important bugs in our application along the way. Just places where I wrote a type annotation down and realized I was calling that somewhere else with the wrong arguments. And I was like, that's not good, especially because a couple of them broke user functionality in important places like managing their accounts. We fixed those, and TypeScript helped us fix them. So that's kind of TypeScript. Here's what it might look like, and that's really hard to see. Can I zoom over here? Not sure. Can everyone see that? Is it clear enough? Okay. People in the back of the room say yes. So I'm using here every modern feature that you might see in Ember today. And I'm assuming things like Ember decorators, which allow you to use a hopefully soon to be stabilized part of the JavaScript spec. The May TC39 meeting has a very good shot at being the meeting which actually moves it along in the stabilization process. We've been saying that for 2 years, so don't hold your breath too much. Cross your fingers and hope. But we can use classes. I strongly recommend that, especially if you're interested in TypeScript, you use classes. We've made TypeScript understand enough of the Ember object model that if you want to do the old-fashioned .extend approach, pass it an object hash, you can do that, but it gets tricksy at times. And because everything just works in the new class-based world, if you're using decorators, that's what we're recommending people do. So what we're doing here is the equivalent of doing export default component.extend, except we're doing it with ES6 class service. And instead of doing bound properties for things like computed properties and session or service injection, etc., what we're actually doing is using decorators. So we're injecting the session service here with a decorator at service. And that does exactly what binding it would do on the .extend hash, but we write it in line. And we annotate that. We say, hey, this has the type of session, which we would get by doing export default class session extend service off in the session module. Computed property here with an ES5 getter. If we wanted it to be writable and do a, let me cover read-only first. There are decorators for all of the macros that you would be used to from Ember computed macros stuff. So read-only and one-way and everything else. And here, I missed a type annotation. Right now, user has the special magical type any. And any is TypeScript's way of giving you an escape hatch. You don't normally want to do what I did here and leave it off. This was an accident. But there are times when you actually do want to say any. And any is just your way of saying, seriously, you can pass me anything in a method, or this thing coming in might be anything. I'll be smart enough to handle it safely. And TypeScript gives you some tools so that you can say, this came in as an any, it's coming out as a string, or it's coming out as an object literal, or something like that. So that you can do things where you're getting unconstrained data from outside your app, or something like that. Do the kind of dynamic runtime checking that you would, and use that. TypeScript will actually say, hey, you've checked, this thing is type of string. Now you can use it as a string, and I'll say, yeah, this has length properties on it, etc. In this case, we should probably have a user type defined somewhere and annotate this, :user after user there. The computed after that is exactly what you would normally pass to as the first argument to a computed property binding in your Ember extends, except that it's a decorator. So you're passing in the keys. If you haven't seen that annotation before, That's shortcut if you're pulling multiple properties off of the same object and computing on both of them. Here, I'm using stuff that lands as a combination of @compute. Well, you can do this with @computed. It plays best with Ember 3.1 or later, because you'll note that I don't have this.get username or this.get user.email. I'm just doing this.user.name and .email. If you're using Ember 3.1 or later, you get that. And it makes the type checking much nicer. Now, we did actually make the types work so that when you're using string keys, it works. Unfortunately, TypeScript doesn't and can't know whether user.name as a string is a nested property lookup or a property on this object inside square brackets named user.name. So writing it for the this.get or this.set style of things with nested properties is painful. I'm sorry. There's just no way around it. You end up writing things like this.get user.get name, or if you're not doing nested or chained gets, if you like me prefer to do the get on the outside, you do get this, comma, user, close parens, comma, name, and it's awful. And our code base is full of that because we, did this before Ember 3.1 landed. But if you can get to Ember 3.1, it's beautiful and magical. And some of the examples that Isaac showed in our earlier session just become way cleaner and nicer because you can just do things like, these user names and emails. You could do a destructuring binding. You could say const curly braces name, comma, email equals this.name or this.user and destructure. That's not TypeScript specific, but we sure like it when we're writing TypeScript because it just makes things a lot cleaner and nicer. You have an object constructor. It's worth note if you're using ES6 classes going forward, whether you're using TypeScript or not, you want to use super, not this._super. Pretty much every day in the Ember Slack, people come in and say something's broken, and I ask a code sample, and they have this._super in a class method instead of the old Ember object method, and I say, well, there's your problem. It's easy to forget, but use super, and you can do whatever other setup there. And then you have actions, which are also bound by decorators. So you just do, instead of actions hash with update email inside it, you just decorate a method, and you get all the things you're used to with it being properly bound to the component context or the controller context. I'm showing a component here, but all of this is equally applicable for a controller. You get currying in the template invocation, just like you're used to. This is an action, just like you're used to. I started to build out an example and then realized my slide was not going to fit anymore. But you could say this update email is going to run a fetch call, so it's going to return a promise. And maybe it's a string if there's an error, and null if there's nothing there. This little pipe here is one of my favorite things in TypeScript. You can say this returns, or this is, this or that. So here, this promise would be a promise of a string or of null. It's really handy, especially because we deal with types that are one thing or another thing often. So if you see that, if you're looking at TypeScript code, that's it. So this is a good basic high-level picture of the kinds of things you might expect to see using Ember and TypeScript today.
Is that
Go back.
just
Yep.
out of the box 3.1, or did you have to pull in Ember decorators separately?
Ember decorators we pull in separately.
Okay.
The plan is for most of Ember decorators to become part of Ember once the spec stabilizes. We don't want to stabilize it until the spec stabilizes. But Chris Garrett which is at Pazurak online, PZURAQ, if you see him around. He's done a ton of work both on making classes work, and in fact, true story, ES6 classes work all the way back to Ember 1.12. So you can start moving to this world today if you like. Ember decorators, I think, also work all the way back that far, because where Chris works, they have a couple apps that they haven't been able to get past 1.12. So he's really motivated for all of this stuff to be very backwards compatible.
And do you feel like it's stable enough that you guys are using?
We're using it exhaustively in our code base. The spec changes that may land for it would change how Ember decorators has to be implemented internally, but they won't change the consumer API at all. So they're pretty safe and pretty stable.
Since we're already
question
Yeah.
about this slide. So this tells me that if you say that it allows a string, say for example, that null is not automatically included in that, so if you try and pass null, you're going to get an error?
Yes, if you use this TypeScript config settings that we generate for you. TypeScript has a number of dials you can turn on it that let you be more or less strict in your type checking. Personally, I don't think that having those settings dialed back is very helpful. You're not getting most of the benefits that the compiler can give you. You are doing more of the work, so you kind of have the cost-benefit ratio at its worst at that point. The ember-cli-typescript add-on generates a good TypeScript config for you that just makes Ember stuff work out of the box and has this, in the release we're probably cutting Monday, has all the strictness settings dialed down as far as they will go. My app has them almost as loose as they will go because we didn't have good enough type definitions when we started over a year ago to be able to support it. We do today, and in a little bit I'll show you an app that I commend as an example that is a 100% open source, 100% TypeScript Ember app that has all the strictness settings dialed down as far as they will go. And it's a really neat piece of example code. It's a large Ember app. So that one I expect actually to become a good example Ember app just because of its size, as well as a good example TypeScript Ember app. Other questions on this slide? Cool. There are downsides. I may be a terrible salesman, but I'm going to tell you the downsides. The biggest one is Ember data is not friendly to classes without decorators. Everything I just showed you, you can make work in ES6 classes without decorators, though with some performance trade-offs in components and controllers and all of those kinds of contexts, routes, etc., but not Ember data. Ember data leans too hard on a number of things, including old style, not ES5, proxies. And basically, Ember data is just not much fun. If you can use decorators, which you should if you can, it's fine. You can use attr, for example. I'll show that. But it's not good. The workaround ends up being, to make things play nicely with the type checker, you write this, which looks kind of like what you're used to, but also really not like what you're used to. So what you're seeing here is we're writing a class definition that is extending from an old style Ember object definition with an empty class body afterwards. This immediate open and close curly brace at the very end there is just an empty class body. Now, this works because, in fact, the class extension thing is always doing this with things under the hood, because most of the Ember object classes that we're used to using are things like component is, Ember object.extend with these things inside it. So this does work, but it's really weird. It doesn't have any weird side effects with the exception of one that I should tell you about right now. If you do class, you cannot do .extend from something that's been defined as a class. You can go from extend to class, but you can't go from class back into the old world. So if you have really deep inheritance hierarchies today, you want to make sure that only the root levels are what you start with converting to classes, and then you can push back up. And again, that's actually not TypeScript specific. That's ES6 classes in Ember specific. But we feel it very directly in TypeScript because we do recommend that you use classes because that's where you get the best inference and help from the compiler. This is what it looks like if you use mixins. It's much nicer. In fact, because of how attr works and the way deserializers tend to work in Ember data, the way that a number of people have recommended that you do this, and I go back and forth, I feel some discomfort either way, is in fact to drop the invocation from @attr as the string and number in quotes there, and just have them be the bare decorator style. So it would just read @attr name : string. You can do that and it will work just fine. This feels frustrating because you're writing string twice and number twice here. The reason we have to do that, and the reason why we have to do a number of things that way, is because decorators, as they stand today in TypeScript, aren't allowed to inform the type of the thing that they're decorating. So they can't, when you're decorating a field, there are also decorators for classes, like tag name, for example. They can't touch the type of the thing they're decorating. They essentially have to just leave that alone. It's possible that'll change in the future, but we're also continuing to think about the ergonomics of using decorators and whatnot in contexts like this that use TypeScript. But with the guarantee, and I'll talk about this more at the end, that even insofar as these things become better supported with TypeScript in Ember itself, rather than just with add-ons, it'll always just work right out of the box in plain old JavaScript. There's no interest, neither from the TypeScript team, like the ember-cli TypeScript team, nor from any of the Ember core team in doing what Angular has done and essentially requiring TypeScript and reflecting TypeScript type data to runtime. We're not doing that. We're always going to be JavaScript first and TypeScript as an enhancement. Mixins. We just saw some really interesting, cool uses of mixins in the previous talk. Don't use them. Mixins don't play well in ES6 class world in general. And typing mixins, like writing type definitions that play nicely with them, we've gotten them to mostly work sometimes. And a mixin ends up being, as I said a minute ago about the extends thing, it's just kind of an argument passed into a .extend. But .extend gets kind of weird, and getting types to sort nicely with mixins is not good. But my experience on our application has been, and as I talk to others in the community, we find the same. There are alternatives, and they actually end up working better and having less pain over time for us. As much as possible for behavior, we find that we get a lot better reliability and testability and predictability out of just using pure functions. Same input, same output. That makes it very testable. And instead of trying to have shared behavior that comes in through a mix-in, and then you're always kind of doing the dance of chasing down where a given action is invoked or where a given property is defined or things that way, it's always just on the object. For shared data and behavior, if you do have a reason that you need that, I recommend that you carefully use traditional inheritance. Don't try to do multiple inheritance, which is essentially what mixins are giving you. And if you can, prefer to compose things as just properties that sit on an object instead. And our experience has been that as we migrate toward this, we have a much easier time maintaining and testing and otherwise just keeping a handle on the complexity of our code. The most painful parts of our code base, even without the TypeScript question, have been mix-in driven pieces of our code. Maybe we're just bad at using mix-ins, but if so, we are bad at using mix-ins, and taking these tacks has solved a lot of those problems for us. To the example that we saw earlier with mixed-in behavior, I think a lot of that in that scenario I would use inheritance for, rather than trying to do mix-in multiple inheritance to accomplish it. Also, in a lot of cases, you actually can just write standalone functions that will give you a lot of the benefits that you're looking for, and in our experience, better testability, better isolation, etc. Certainly these things are true in TypeScript. These things I'll type check in TypeScript. Not so much with mix-ins. And this is similarly, I got a tweet back as I was tweeting about this issue a couple days ago, and someone noted that in their applications, they've just switched to using a mix of behavioral components and presentational components, where the behavioral component wraps around presentational components. And presentational components are just pure UI. In the React world, they would be pure functional components. They have no state of their own, etc. We do very similarly. We have a lot of components that are just dumb UI, and then we have higher level components which manage the behavior, fire actions, etc. And similarly, using that pattern rather than mix-ins has solved a lot of our pain points at the component and rendering level. So that's some idea of where TypeScript in Ember is today. Mostly it works really well. You can write components, and I'll show some of those to you in a minute in the app that I was talking about that's totally open source. Show you kind of how it plays out a little bit larger scale. But I also want to talk, before I do that, about some of the places we're going with TypeScript in hopefully the next couple months, certainly over the next year. One of those is an RFC that I have started writing, and courtesy of prepping for a talk I was giving at work and this talk and a few other things, I have not finished writing yet, but will probably be open sometime during May, which will add official support. We've got to work out the mechanics of this, which is why it's going through an RFC, for TypeScript shipping with Ember. Now, as I said a couple minutes ago, that is not like Angular being all TypeScript all the time. If you don't really like TypeScript, that's okay. There are trade-offs with it. There will remain trade-offs with it even as we continue to march forward and decorators are standardized and all these other things. Some people just don't love typed languages, and they do have a cost. Writing type annotations, even as much as TypeScript can infer, it has a cost. There are overhead to it. There's maintenance overhead to it. In our particular context, with the particular developers I'm working with, I'm a typed functional programming nerd. A lot of the people on my team are C# developers. It's a really good fit for the way we already work. It might not be for your team. So one of our goals with that RFC is to make it so that your experience gets better, regardless of whether you're a TypeScript user or a JavaScript user. And I'll explain how that works in a minute. But your experience doesn't get worse, ever, because we're supporting TypeScript officially. And supporting TypeScript officially will mean, in a lot of cases, even more of Ember itself will be written in TypeScript. A lot of it already is. The Glimmer rendering engine is all TypeScript, top to bottom at this point. Much more of Ember will continue to be written in TypeScript because it's really useful, especially in library code. And doing that will let us automatically generate, rather than manually writing, type definitions for Ember. And those will be inherently accurate because they'll be type checked against the actual Ember code that's being written and generating the framework that you're actually using. We have to figure out some things around that, though, like what does semantic versioning and stability mean in terms of type definitions? What does it mean if we find a soundness problem in the type definitions where we were letting you pass in something that was actually wrong and we tighten it down? Is it a breaking change for us to fix a problem with the type definitions that, your code type checked, and then in Ember 3.5 your code type checked, and then in 3.6 it doesn't anymore, even though your code didn't change? Or I don't know. These are the kinds of questions that we're going to try to hash out over the life of the RFC, is figure out how do we fit this into Ember's existing stability without stagnation story. How do we continue to keep those guarantees of your experience as a developer, that the benefits that we all get from that don't go away just because we're pulling in TypeScript? The other thing that I've been working on for 8 weeks now, slowly but steadily, is we're going to have a quest issue where we try to write type definitions and or convert to TypeScript existing add-ons as add-on maintainers want, so that you can have good type definitions and type support for the add-ons that you use every day. The pain point that I didn't mention so far is that most add-ons don't have any type information associated with them. TypeScript has a mechanism for saying, here's a file that defines the types that go with this JavaScript implementation. We've written that for Ember itself, for Ember Data, for a couple of the most highly used add-ons. There's a lot out there that have no type information at all. And so what you get, I mentioned any earlier, what you get is everything is any. You have no idea what anything is. You have none of that help. You're not getting autocomplete from your editor. You're not getting type checking from the compiler. And you're not getting much of anything. So, hopefully, over the next few months, as I hopefully finish this quest issue soon, writing quests is really hard, it turns out, because there's a lot of detail to communicate. Writing quests where you're also teaching people how to write type definitions for TypeScript is even harder because there aren't a lot of good docs on how to write good type defs. The upshot of this should be that over the next 6 months probably, the ecosystem will have better and better and better type definitions. And that means something really interesting. Both of these, I forgot to turn that into notes. You can read some of my notes to myself, what I was going to say. Both the quest to type the ecosystem and getting things into Ember itself will be good for you as a user whether or not you adopt TypeScript. And the reason is that most editors, and this ranges from Vim to Visual Studio, will use TypeScript type definitions if it's available for your JavaScript code, even if you're not a TypeScript user. So you can just be working in your plain old JavaScript code, and you've got Visual Studio Code open, and you're getting documentation, hints, and type checking, and all of the benefits of TypeScript for library code. Hey, you just called fetch with the wrong arguments. Hey, you just called, you didn't set up your ember-cli Mirage stuff correctly here. But without ever using TypeScript yourself, it will genuinely be better for all Ember consumers, everyone building apps and libraries for Ember, for TypeScript support to be there, whether you want to use it or not. And that's one of the reasons that I and a number of other people, including the core team, are enthusiastic about this, because it makes everyone's experience better. And it'll be even more better, extra better, if you are a TypeScript user, but it'll be a net win for everyone. And part of that means that we'll be pretty careful as we evaluate those type definitions, because one of the things that I've talked with a number of people about is bad type definitions are actually worse than no type definitions. Because what you really don't want is for your compiler to lie to you and tell you this is correct when it isn't, or to require you to do something wrong that causes things to fail at runtime. We're going to be validating them well so that it is in fact beneficial to everyone. That is all of my slides. Before we dig in and look at some examples, do people have questions?
So if you have an existing app and you're thinking about TypeScript, what are the kind of, I mean, if you have like a 3.0 app, is it just, and you want to do TypeScript, is it just kind of turnkey and you go?
Yeah.
If you have an older app, what kind of things do you look out for?
So question is, you're converting an existing app, or you have an existing app. Is it fairly turnkey? With which versions is it fairly straightforward? The answer is, as far back as anyone I know of has tried it, which I think is 2.4, it mostly just works. And we've gone really out of our way to make it mostly just work. You type ember install ember-cli TypeScript, it generates the TypeScript configuration for you, and you just start converting files to TypeScript. We do not do any auto conversion for you. We let you change a file from .js to .ts as you go, but everything else will just go. So you change your first file to .ts, and there might be a couple type errors that show up, and you fix them, and along the way you've got Ember serve running, and it runs, and your app live reloads, and everything just does everything you normally expect. The main pain points, like I said, are things like how you write an Ember data model. The easiest place, a colleague of mine got to start a new Ember app on 3.1 with TypeScript and all of this. I was very jealous, because that's certainly going to be the easiest experience, mostly for the reasons it would be the easiest experience without TypeScript. It's just a much nicer spot to be starting. There's no this .get for most things at this point. If you have a proxy, you're still going to be this .getting. Does that answer your question?
Yeah.
One of the recommendations I make along those lines, where to start if you're interested in doing this, is pick modules which have themselves very few dependencies from the rest of your app, so that you don't have to come back and update them again later as you add types. but also use ones that are highly used themselves throughout the rest of your app. So for example, we have a basket service because we're food ordering and you put things in your basket, your cart, to check out and order your food from Wingstop or wherever. We left that almost till last, and if I were starting over again, it would be one of the very first things I converted because it has very few dependencies of its own, but it's injected into every stinking controller and route and component everywhere in the application because stuff has to interact with the basket. We're doing e-commerce. It's literally the primary thing we're doing. So find the things in your app if you're converting, find the things that are used most and have the fewest dependencies themselves and convert those first. Among other things, you'll get the highest yield from those. And as for another, converting them late in the process of converting your application is painful. Very, very painful. You can talk to me in last November about that and hear how grouchy I was as I realized my mistake. Other questions?
How much does it add to your build times, especially like the refresh warm rebuilds?
I don't know. The question was, how much does it impact your build times? There is some. Usually, especially with the release we're shipping, like I said, hopefully on Monday, it's not in the top number of consumers on a rebuild. So Rollup is ahead of it, Babel's ahead of it, Template Compiler is often ahead of it. It does add some, and especially on first build, it definitely adds some. Now, one neat thing, Babel 7 includes the ability to parse TypeScript, and so right now, our compiler flow compiles everything through TypeScript and then pipes that into Babel, and then Babel runs on it and generates the output. But because Babel 7 supports TypeScript, we're actually probably in probably a month or two, we'll have a version out that just goes back to just using Babel, and we'll have a type checking step that runs sort of in parallel and will fail your build if you have a type error, at least if you've opted into that. But we'll be back to having the plain old build times that everybody's used to having. We'll have the same Babel 7 build times that everybody does, which will be really nice.